Hello and welcome back to the course on machine learning. In today's tutorial, I'm going to show you my solution of the challenge that I threw at you last time. So in the previous tutorial, we had the challenge to calculate the posterior probability of somebody being a person that drives to work, given that they are placed in the position where we are placing the new observation for our dataset. So basically, what is the likelihood of that new observation representing a person who drives to work? And the way we need to calculate it is using the Bayes theorem, which is right in front of us. And so now we're going to walk through it. First, we're going to calculate the prior probability. Then we're going to calculate the marginal likelihood. And then we're going to calculate the likelihood. And you can compare along the way if you got the same results. So let's go through it. So there's our data set, and now let's move it to the left to make some space. And the first thing we're going to calculate is the prior probability. The prior probability, there's kind of two ways to think about it. So the first way to think about it is if I just randomly select a person from our data set right now, so not including the gray dot, not including the new data point, if I randomly select a person from there, what is the likelihood of them being a person who drives to work, right? So that'll be just the answer to that is the number of green dots over the total number of dots. The other way to think about it is if I just randomly throw a new data point into our data set, right? Just randomly. And without knowing anything about their age or salary, then just knowing all of this prior information that we have, the green dots and the red dots, what is the likelihood of that person that we're adding? What is their likelihood to be a person who drives to work? Again, it's very simple because we don't have any other choice but to calculate the probability and assign the probability just based on what we know. And that is just to take the green dots, so the 20 green dots, divide by the total number of dots here and assign that as a probability. So we don't have any other choice. And therefore, that's what it's calculated as. So the probability of somebody being a person who drives to work, or a random dot selected out of our existing dots being a person who drives to work, is the number of drivers, which is 20, divided by total observation, which is 30. So there we go, 20 over 30. So that was the prior probability. We've done that. Next one is the marginal likelihood. So let's go ahead and calculate that. And you'll find that the marginal likelihood is actually going to be exactly the same as in the previous tutorial. And we'll talk about this separately. So again, we're going to draw the circle around our observation. We're going to remove observation so it's not in the way. Then we're going to shade in this area. And so now the marginal likelihood is the question, what is the likelihood of, if I just pick a random dot from our data set, just randomly, what is the likelihood that I'm going to pick one out of here? So the reason why we put X here is because what is the likelihood of me picking a observation that exhibits features similar to the features of that point that we are adding to our dataset. So the point we're adding to our dataset, we've just removed it, it's over there. And we've agreed that any dot inside the circle is deemed to be similar to that dot, or in other words, deemed to be exhibiting similar features, so similar age and similar salary to that dot. And therefore, that's what we're calculating. So P of X is very simple. We just need to calculate the number of similar observations, so number of observations that actually fall in here, which is 4, divide by the total number of observations, which is 30. So that'll give us the likelihood of a new dot falling in here, or the likelihood of, if we just pick out a random dot from our dataset right now, then the likelihood of it being one of these is 4 over 30. There we go, 4 over 30. All right, so that is our marginal likelihood done. And now we're going to move on just the likelihood. And this time it's going to be the likelihood of somebody exhibiting the features of X, or being similar to the data point that we're adding, given that we're only looking at people who are driving to work. So let's have a look at that. Here's our data set. And again, we're going to draw the circle around our data point, take it out, and then add that shading. So now the question is, given that we're only dealing with people who drive to work, what is the likelihood that if we pick one of them, that person will be exhibiting features similar to X? So because we're only dealing with the people who drive to work, we can forget about the red dots. There you go, they're shaded, they're faded out, and now we're only dealing with the green dots. So the question is, given that we're selecting a random point out of all of the people that drive, so this vertical bar drives means given that a person drives to work, so we're selecting a random point out of these, what is the likelihood that they will exhibit features similar to X, which we agreed is the same as they fall inside this circle. And the likelihood of that is 1 over the total number of green dots. So there we go. P of X, given that they drive to work, is the number of similar observations among those who walk. So inside here is 1. Similar meaning similar to our new point that we're adding. And then divided by the total number of walkers. And that's 20. So 1 over 20, that is our likelihood. There we go. So now we can plug these into the formula, calculate the posterior probability. So it's going to be 1 over 20 times 20 over 30 divided by 4 over 30, and it's 0.25, so 25%. So there we go. That was step 2 of our naive Bayes algorithm or naive Bayes classifier. Hopefully you were able to follow along, and also that I hope that you had a chance to perform that exercise on your own and you got a similar result. And that's it for today. I look forward to seeing you next time. And until then, enjoy machine learning.